Right. Thank you everyone for joining. Today we're going to talk about the runtime fabric on self-managed Kubernetes. And we have two speakers today. One is Lakshmi, is part of the MuleSoft team, and then we have Mani as well. I'll first pass the stage to Lakshmi Narayan. Uh, we have Mani, and then Mani is going to run a few slides as well. Then there's a hands-on presentation from Mani. The presentation is about hour and a half, including the demo. We have some trivia questions as well, like every other time. The first correct answer winners would receive the prizes, and I'll share the prize details individually with the winners. Please make it interactive. Make use of the chat function uh, in the web link for any questions. And if we have the answer, we'll answer in the chat. If we need to break the speaker, we'll do that. And if we don't have the answer, we'll share our contact information, and you can reach out to us over the email, and we'll get the answer for you. With that, I just want to highlight the Trailblazer event that's happening April 23, 26. It's talking about Salesforce, MuleSoft, all those events where developers and architects come in place, they learn, they collaborate, they talk about it. All this information will be available over the presentation that we'll share. If you want more details, you can talk about with your representation, or you can shoot us an email. With that, I'm going to ask Lakshmi to start on that.
Thanks, Rishupal. Can you hear me?
You're good to go.
Okay, yeah, thank you. Hi, everyone. My name is Lakshmi Narayan. I'm part of the Customer Success Strategy and Architecture team at MuleSoft. So the CSSA team, we work with customers to provide strategic and tactical guidance on how best to utilize the platform, how to leverage the capabilities that is available out of the box, how to be successful in the long run, how to architect, how to have well-defined architectures and ensure that the implementations are successful. So thank you all for joining. I'm based out of Toronto, Canada, and I will be doing a presentation. Like I'll be talking over what is Runtime Fabric on self-managed. We'll be focusing on the self-managed Kubernetes offering because that is the newer offering and the one that is getting widely adopted by customers. We'll talk about some of the differences with the appliance model. We'll talk about the architecture of the self-managed Kubernetes model, and we'll also talk about an important topic: how Ingress. How can you what you should do to make your Ingress controller work with the self-managed Kubernetes offering, because that is one of the critical aspects of the self-managed Kubernetes offering, and which customers are responsible for. So we'll talk about what are the options that you have to set up your Ingress controller, and how does RTF internally work with your Ingress controller to create the Ingress resources. And then finally, Mani will demo everything that we talk about. So he'll be installing an RTF cluster, he'll be installing an Ingress controller, deploying an application, and showing you how to implement end-to-end security for your Mule applications. All right, next slide, please. All right, to start off, Runtime Fabric, Anypoint Runtime Fabric is MuleSoft's container service. So that allows you to run Mule applications, your API proxies in a containerized environment. So there was a need to containerize the Mule images, and what Runtime Fabric does is it provides you a containerized environment where you can run your Mule applications in containers in separate pods, and you can manage all of them from the control plane. So with Runtime Fabric, you get multi-cloud support. So you can deploy your Mule runtimes across your cloud environments like Azure, AWS, GCP, or even your bare metal servers. You can have virtual machines running on your bare metal servers. You can install Runtime Fabric on that as well. And you can now register and connect all of these different environments in the Anypoint platform and manage all the different Runtime Fabric clusters from one single pane of glass. And the benefits of containerization in general, you get reliability through application isolation. So every application deployed to a containerized environment will reside in its own container. In a new on-prem standalone server, you have one JVM which is hosting like uh, hundreds of mule applications. And if one mule application has some issue, or it's consuming more memory or CPU, is going to end up affecting all the applications running in that server and eventually bringing down the server itself. But in the case of a containerized environment, you have applications running in their own containers, and you get their application isolation and reliability through that isolation. You also get zero downtime when you want to redeploy applications or make changes to a particular application. Kubernetes, the container orchestrator, will automatically spin up another replica of the mule application so that your existing traffic is not implemented. And you can, once your deployment is complete, it will again route the traffic back to the latest deployment. In this way, your consumers don't see any impact and you get zero downtime. You can do horizontal scaling. You can have multiple replicas of the same mule application. If you find that you need more capacity, your mule application requires more capacity, and you need to add more instances to your mule application, you can do that. You can add more replicas and then segregate those replicas so that you can do horizontal scaling and you get high availability as well. These are some of the advantages of containerization. Now, when we come to Runtime Fabric, there are two different offerings that MuleSoft provides. The first one is what you see here, which is Runtime Fabric on VMs or bare metal. This is also known as the appliance model. So in this case, we provide a runtime fabric as an appliance with all the infrastructure components packaged within it. When I mean infrastructure components, I mean Docker, Kubernetes, everything is packaged within it. And you will install this version on virtual machines that you operate and manage. So you can have virtual machines on your AWS environment, on your Google GCP, on Azure, or you can just have VMs on your bare metal servers. You can install RTF on your VMs, and then deploy applications into it. The Kubernetes flavor, I said we provide an appliance with Docker and Kubernetes packaged within it, right? So the Kubernetes flavor that is used in the appliance model is Gravity, and yeah, so it is another open source product, and that is the Kubernetes flavor used within the appliance model. And in the appliance model, you also get all the runtime fabric services packaged within it. You get an Ingress controller. We'll talk about what Ingress is. It's basically an inbound load balancer. So everything is packaged within it. And yeah, so you can now install it across your virtual machines in different environments. Next slide, please. Okay. The next offering that we provide is Runtime Fabric on self-managed Kubernetes. And this is what we'll be focusing on today. And this is a version of Runtime Fabric which you install on your own Kubernetes environment. So as a customer, you can bring your existing AKS, AKS. AKS stands for Amazon Elastic Kubernetes Service, or Azure Kubernetes Service. Sorry, AKS stands for Azure Kubernetes Service. EKS stands for Amazon Elastic Kubernetes Service, or a GKE, Google Kubernetes Engine. So you can bring any one of these Kubernetes clusters and install RTF within that cluster. So Runtime Fabric and its services would get installed within your existing cluster that you may operate, and will now manage and operate the Mule applications as you deploy it in the cluster. So it is, we look at what are the differences, what are the components what are the differences between appliance and this one, and also what are the components involved in both. Next slide, please. Right. So in the left side is the RTF on VM bare metal, or the appliance model, where like I told you, it's packaged as an appliance containing, so in a Kubernetes cluster, you have both controller and worker nodes. The worker nodes will host the applications. So the Mule applications that you deploy, how many ever instances you deploy, they all get deployed to the worker nodes. The controller nodes is similar. It would have the Ingress load balancer, the RTF agent, that talks to the control plane, the MuleSoft control plane. And all of these are packaged and provided to you. So all you do is you deploy your Mule applications to the worker nodes and then manage the applications from the endpoint control plane. On the right side, you no longer need to provision separate controller nodes. In the self-managed Kubernetes model, all you do is you provision a dedicated worker node pool where you're going to deploy your Mule applications. So you bring in your own AKS, EKS, or GKE cluster, and within that cluster, you provision your worker node pool into which the Mule applications get deployed. And I'll talk about when you install Runtime Fabric within this worker node pool, what are the services that get deployed. I'll talk about it in detail. In addition to the Runtime Fabric services, you'll also be installing an Ingress controller because you have to receive traffic from the external world and route it to your Mule applications. So you will have to take care of that. So let us understand, next slide, please. Let us understand what are some of the differences in both. So if you see in the self-managed, some of major differences, like I told you, both Runtime Fabric on self-managed Kubernetes and on VM sub bare metal, which is the appliance model, both are for deploying Mule APIs. So you cannot deploy other non-Mule APIs as of now into any of these Runtime Fabrics. The the Kubernetes and Docker components are included in the in the appliance model. So I told you Gravity is the flavor of Kubernetes used there. In the self-managed Kubernetes model, you bring in your own AKS, EKS, or GK cluster, and you then MuleSoft will supply the Docker images to to instantiate the Mule runtimes. The OS, in the case of appliance, only Red Hat Enterprise Linux and CentOS is supported. Whereas for self-managed Kubernetes, any Linux or OS distribution that is compatible with your AKS, EKS, or GK environment is supported. No, node autoscaling is not supported in the appliance model. Whereas on self-managed Kubernetes, you can leverage your AWS, GKE, or Azure capabilities to perform node autoscaling depending on the needs. External log forwarding, it is packaged in the appliance model. It is included within the RTF cluster. So an external log forwarding agent is packaged within the RTF cluster, and you can configure it to send your logs to any external sources. In the self-managed Kubernetes, you can bring your own external forwarder. It's not packaged automatically, but you have the ability to configure an external log forwarding agent and send it to whatever external system of your choice, like Sumo Logic, Elk, Splunk, wherever you want to send it, you can do that. Similarly, for an internal load balancer, in the appliance model, it is included within the RTF cluster. It sits within the controller node. In the self-managed Kubernetes model, it is the customer's responsibility to install an Ingress controller, which could be anything. You could anything that is compatible with your AKS, EKS, or GKE environment, like Nginx, HA proxy. You can install any Ingress controller that is compatible with your environment, and then you'll have to manage the Ingress controller and make sure that you route traffic to your Mule applications accordingly. Anypoint security edge. So your edge policies are supported in the runtime fabric on the appliance model, whereas they are not supported in the self-managed Kubernetes model. Similarly, in the for monitoring, the final thing is wrong. Ops Center is something that is included. Oh, it's actually correct. Sorry, the Ops Center is included in the appliance model. So Ops Center is something that works with Gravity. Like I told you, Gravity is the flavor of Kubernetes used within the RTF appliance model. And Ops Center is an out-of-the-box capability that Gravity provides to monitor your RTF infrastructure. Whereas in self-managed Kubernetes, you don't get Ops Center, but you can leverage whatever monitoring solution that you're using with your AKS, EKS, or GKE environment. So if you're using Prometheus or whatever, like for AWS, you might be using CloudWatch. You can leverage the same monitoring solution to monitor your RTF cluster as well. And this is infrastructure monitoring. For Mule application monitoring, you can use anypoint monitoring, which is part of the anypoint control plane. Next slide, please. So this is how the components sit. So when you see the first part, which is the Anypoint platform, so this is MuleSoft's provided Anypoint platform, which has individual services like access management, Runtime Manager, Visualizer, Anypoint monitoring. So these are all services that are hosted in MuleSoft's cloud environment, and these enable you to manage your access, manage your Mule applications, deploy Mule applications. It provides a UI to deploy Mule applications, to monitor your Mule applications, to design Mule applications. So this is the Anypoint platform. And then below what you see is your Runtime Fabric cluster, so which is installed in your own AKS, EKS, or GKE environment. So you bring your own AKS, EKS, GKE cluster, you install Runtime Fabric within it, and deploy Mule applications inside that. And you now interact with the Anypoint platform to manage all your Mule applications from the Anypoint control plane, which is the Anypoint platform. Next slide, please. So the architecture of the Anypoint self-managed Kubernetes model, I wanted to go through like what are the architectural components, and also go through what is managed by MuleSoft and what is managed by the customer. Now, the runtime fabric on self-managed Kubernetes model was released to give more flexibility to customers. So in the appliance model, like I told you, everything was packaged, but there was very little scope for changes. Like if you wanted to use a different Ingress controller, you couldn't do that. If you wanted to use a different log forwarding agent, you couldn't do that. You had to rely on Ops Center for monitoring. So there was a lot of restrictions in the appliance model, and self-managed Kubernetes was released to give customers more flexibility. So customers can control a lot of things, but at the same time, now they are responsible. MuleSoft doesn't provide those components, so customers are now responsible for providing components for log forwarding, monitoring, and all those things. So it was released to provide more flexibility and help customers. It is also very lightweight. If you see the runtime fabric on appliance model, everything is packaged, and the whole installation, it's a very heavy model. The installation will take you many hours, depending on the where you're installing, and you have to have all the scripts ready and all that. Whereas the self-managed Kubernetes model is very lightweight. So what it does is, it basically, when you install the self-managed Kubernetes RTF offering into your AKS, EKS, or GKE cluster, all it does is it installs certain services. And if you see, one of the most important services is the RTF agent. So in the diagram, if you see, there is a blue color box which says agent within the cluster. So that is one of the most important components in the self-managed Kubernetes model. Now, this agent is responsible for talking to the Anypoint platform control plane. So whenever, if it has to, understand when you do an application deployment, if it has to understand how many replicas for that application, what is the CPU and memory for that application. So this agent talks to the control plane, talks to Runtime Manager to get all that information. Similarly, this agent also talks to the container registry. So if you deploy a Mule application, it needs a Mule runtime running within that container to run the Mule application, right? So this agent is responsible for talking to the Mule container registry and downloading the Mule images and instantiating the containers. This agent is also, responsible for sending monitoring data and analytics data back to the control plane, so that you can understand how your APIs are performing by looking at them in the Anypoint platform control plane, in Anypoint monitoring or any other this thing. So this agent is very important and is one of the services. It's just a service that runs inside your Kubernetes cluster. And in addition to that, if you see the ones in orange, those are all things that you as a customer would bring in. So you can install an Ingress controller, like I told you, an Ingress controller which is compatible with your AKS, EKS, or GKE environment. It could be anything like Nginx, HA proxy, whatever is compatible. Your EKS, AKS management plane, it's under your control. So how you manage your cluster, the Kubernetes cluster, is completely up to you. So all from a MuleSoft perspective, the RTF services like the RTF agent, the monitoring service, and then the Mule applications. This is what MuleSoft will manage. The remaining infrastructure, Ingress, log forwarding, monitoring, all this is managed by the customer. So you have flexibility to use whatever monitoring infrastructure that you use, whatever log forwarding capability you have. You have that flexibility to use whatever is compatible with your environment. Next slide, please. So this is very important. Since I told you there is a lot of flexibility with Runtime Fabric on self-managed Kubernetes, you should also understand what is managed by MuleSoft and what is managed by customer. The reason I say that is, if something that is managed by the customer, if you find an issue and you need help debugging that issue, you raise a support ticket. It is outside MuleSoft's support scope, and you will not get support for that. Neither will you get a point of view. If you want to understand what Ingress controller I can use, MuleSoft will not have a point of view on that. All we can say is you can use any Ingress controller that is compatible with your AKS or EKS or GKE cluster. So it is important to understand the shared responsibility model. So MuleSoft is responsible for the RTF agent, for the Mule runtime, for all RTF services that get installed into your Kubernetes cluster. Okay, so it's just MuleSoft responsible for the runtime fabric services, which is the runtime fabric agent, the Mule runtime, making sure that the Mule runtime is up to date, the components, how they interact, and then your Mule applications themselves. If you have issues with that, yes, MuleSoft will help you with that. Everything else, like the Ingress controller, the host operating system, your Kubernetes cluster, your the node pools that you provision, log forwarding, all this is under customer responsibility. So you have flexibility, but you also are now responsible. So you can choose whatever is compatible and work accordingly. RTF will now sit inside your existing infrastructure and work seamlessly with all your existing infrastructure components. That's the whole concept here. Next slide, please. Okay, so we have a first trivia question. Ishupal, I think there's a question that just came up. Maybe I'll just address that before. So the blue components, are they MuleSoft managed or MuleSoft supported? The blue ones, yes, they are the MuleSoft. They are MuleSoft managed as well as MuleSoft supported. So when you install Runtime Fabric, it will when you do the installation, MuleSoft will automatically install the Runtime Fabric components. MuleSoft will take care of downloading the images, which will spin up the Mule runtime and all the deployment resources required. So MuleSoft, it's both MuleSoft managed, and also tomorrow, if you need any help with managing those, or if you have any issues, MuleSoft will provide support for these components. The orange ones, you take care of the installation, you take care of the configuration, and you take care of the support and maintenance as well. Okay, so we can now move on to the trivia question one.
So there's another question. What is CRI, NSCNI? I don't know what that means.
I Oh yeah, can you elaborate on that? I don't know what CRI is.
Yeah, Francis.
Are you talking?
All right, we'll proceed. And Francis, if you can type in, and we'll come to the question later.
That's the container runtime interface.
Right, but what is the question? I mean,
What is the question?
Please clear the question. You can type it over here.
All right, we'll take it up if the question comes. Okay. Oh, so he just wanted the thing. Okay, so this is the first question. So one hint here: if you have multiple options in the answers, please mention all the answers. So first question: which of the following configurations are customers' responsibility when adopting self-managed Kubernetes? The runtime fabric agent, Ingress controller, and external load balancing, external log forwarding, all of the above. Okay.
So we have the answer now, Lakshmi, right?
Yes. Yeah. The Francis gave
Francis, Francis get, yep.
yeah, correct answer. A lot of you said all of the above, but I told you the runtime fabric agent will be MuleSoft will provide and support it. The Ingress control, external log forwarding, and external load balancing is the customer's responsibility. So it's B and C. That's the correct answer. All right. So with regards to runtime fabric on self-managed Kubernetes, I told you the installation is simple. You'll actually see in the demo, like installation won't take more than a few minutes. It is very lightweight. All it does is it installs certain RTF services, which will talk to the different components, will talk to the control plane and all, and it is very easy to. It is lightweight. You are having your own cluster in which you are installing RTF, and it is easy to manage. You have a lot of flexibility. So one thing that customers we've seen after the self-managed Kubernetes offering went live was customers had some challenges with regards to Ingress. Now, again, Ingress is customer's responsibility, so you can install any Ingress any Ingress controller of your choice that is compatible with your environment. But with RTF version 1.11, we released a lot of features that makes it easier for customers to manage the Ingress configurations. So I just wanted to tell you how that works and what are the steps you should do to get your Ingress working on the self-managed Kubernetes offering. So first of all, what is a Kubernetes Ingress? It is a high-level abstraction governing how your external users access services running in your Kubernetes cluster. And it is HTTP or HTTPS based. It takes care of routing, if you want to do configure policies for resilience like rate limiting, or if you want to do content-based routing, if you want to do authentication, you can do all of this with Ingress. It is basically an API object that describes the routing rules for your traffic into the application running within your Kubernetes cluster. So now you have Mule applications running in your Kubernetes cluster. You want to expose them to the external world. So Ingress is a way to do that. It is basically it will it will take care of load balancing across your different application instances and expose your applications to the external world. So it is a stable and routable endpoint that can communicate with your backend applications. So what you should do to get your Ingress working in your self-managed Kubernetes model. So okay, before that, like I told you, with the latest, with 1.11, if you're using Runtime Fabric on self-managed Kubernetes, it's highly recommended to use version 1.11 or above, because we released, I believe, in 1.9 or 1.10 was the version when the self-managed Kubernetes model was released. But with 1.11, it is very easy. There was a lot of features added for easy Ingress configuration. So what was added was the points that you just see. So you have the ability to now configure custom Ingress resource templates, and just like you would do in a native Kubernetes world. And this lets you have for the following features. You can have multiple Ingress controllers within the same RTF instance. So you can have an Nginx Ingress controller and a HA proxy. And if you want, take for example, if your RTF cluster is being used by two different business groups in your organization, and one business group they want to use Nginx as the Ingress controller, and the other one wants to use HA proxy, and all the Mule applications for both the business groups are deployed to the same cluster. Now you can have that. You can have multiple Ingress controllers within the same RTF cluster, and it can work together in tandem to route your traffic. You can have multiple Ingress configurations for each application. So you can do that for each application. If you want to have different rules based on whatever, like if you want to segregate different rules based on traffic or whatever, you can do that as well. If you want to have TLS and HTTPS configurations, like if you want to have certificates configured on your Ingress, you can do that. You can configure your TLS secrets. You can have TLS termination done, or you can have again TLS between the Ingress and the Mule application, which is known as last mile security. You can have all of that configured. You can have then you can also have URL placeholders. So if you're sending the application name as a placeholder in the URL path, the Ingress can now replace the application name with the actual application name and route it to the appropriate application. So you have all these features that were released as part of version 1.11 and above, and it has made it much more easier for customers to manage Ingress configurations. So how does this work? Let's look into it. Next slide, please. So okay, so now you have an RTF on your self-managed Kubernetes. So it's either AKS, EKS, or GKE. You have a cluster. You have installed RTF in it. Everything is fine. Installation was complete. You have deployed Mule applications. Fine. Now you want to expose your Mule application to the external world for your external consumers. So what do you need to do? So first step, your organization's Kubernetes administrator will need to install a Ingress controller. So, like I said, it could be anything that is compatible with your environment. So, anything like Nginx, HAProxy, whatever, you install the Ingress controller. The next step is your Kubernetes admin will then create an Ingress resource template. So, what is an Ingress resource template? It will give you the ability to configure Ingress configurations, like the routing rules that you need. Ishipal, if you can go to the next slide, I'll just show a sample of the Ingress resource template. So this is an example Ingress resource template. So your Kubernetes administrator will need to configure this Ingress resource template. It's a custom Ingress resource template. So this will have like, what is the Ingress class name? So if you are using Nginx or HAProxy, these rules, which Ingress controller should apply these rules, you can specify that using the Ingress class name. You can refer to the Ingress controller in the Ingress class name. Similarly, if you have rules, if you want to do path-based routing or host-based routing, depending on the path routed to this application, or just replace the path, the URL path with this the application name. All those configurations you can specify over here. Similarly, if you want to have TLS secrets, if you want to refer to TLS secret, you can you have your own domain that you might have you purchase your certificate from a certificate authority. You store it as a secret in your Kubernetes cluster, and now you can refer it in the over here in the TLS section. You can refer it so that you can expose your APIs under that domain, your Mule APIs under that domain. So all these configurations, the business group, the environment, all these can be specified in the custom Ingress resource template. So your Kubernetes admin will create this custom Ingress resource template. Now there are two things that you need to understand here. The namespace where you apply the custom Ingress template should be RTF. I'll tell you why, but the namespace should be RTF, and the Ingress class name should be prefixed with RTF hyphen. So what is that? Why we need to do this? So so if it is Nginx, RTF hyphen Nginx, or if it is HAProxy, it's RTF hyphen HAProxy. The reason we do this is, once we do this and apply this at the cluster, once the Kubernetes administrator creates this Ingress resource template and applies it at the cluster, the RTF agent will now understand that this Ingress resource template has to be applied for your Mule applications that get deployed into the RTF cluster. And what it will do, it will create Ingress resources for every Mule application that gets deployed using this Ingress resource template, and it will automatically replace the placeholders. So for example, you see business group environment ID, right? So if you're deploying a Mule application to a particular business group, it will automatically replace the business group ID value with the appropriate business group ID. Similarly, the environment ID, it will replace it with that. So it will know to do this only if you apply it in the RTF namespace. And when it creates the Ingress resource for the Mule application, it will also replace RTF-Nginx with just Nginx. So the Ingress resource is necessary for every Mule application, so that when your traffic actually comes, the Ingress controller will look at the Ingress resource and then apply the appropriate rules while sending traffic to the Mule application. So in a Kubernetes world, you need to have Ingress resources defined for your applications that get deployed. so that the Ingress controller knows what is the routing rules, what should I, how should I route the traffic, what are the things I have to do before routing the traffic. So this template is what will tell. So now RTF is automating that for you. You don't have to create an Ingress resource separately for every application that you deploy into the RTF cluster. Instead, you create one template, which is the Ingress resource template. This is a sample. I'm not saying this is the final one. This is just an example. You create this Ingress resource template. The key point to note is you apply it in the RTF namespace, and the Ingress class name should be prefixed with RTF hyphen. So when you do this, when you apply it once in the cluster, the RTF agent will take care of creating those Ingress resources for every mule application that you deploy. And now that you have your Ingress resources created, the Ingress controller will know how to route the traffic for your mule application. So it's very easy because you don't have to manually create the Ingress resources. You can just whatever configurations you need, specify it in the Ingress resource template, apply it at the cluster level. And this Ingress resource template is for per domain. So if you want to expose your mule APIs under api.123.com, just for example, then you have an Ingress resource template for that domain. Similarly, if you have another domain that you want to deploy, you have another Ingress resource template where you specify the host. If you see under rules, you'll see the host there, right? So you can have the other host specified. For every domain that you want to expose your mule applications APIs under, you will have an Ingress resource template, and you'll apply it once. You'll specify the Ingress class name. So if you, in this case, I'm referring to the Nginx. So I need what I'm telling RTF is that I want Nginx as the Ingress controller for this host name. So if you want to have another HA proxy, you can refer to that RTF-HA proxy. You can do that. So for every domain under which you want to expose your mule APIs, you will create this custom Ingress resource definition and then apply it at the cluster. And RTF will and make sure, again, the important point is apply it at the RTF namespace and make sure that the class name has RTF hyphen prefixed. And the RTF agent will now automatically create, for every mule application that you deploy, it will create the Ingress resource with all these rules and all. It will replace all the dynamic values like the business group ID, environment ID, and it will take care of creating the Ingress resources so that the Ingress controller can automatically route the traffic. It will know how to route the traffic. So, Ishupal, if you go back to that diagram. So yeah, that is how this applies. So the IT administrator would create the custom Ingress resource configuration and apply it at the cluster level in the RTF namespace and RTF agent. So once you have done that, the RTF agent will communicate this to the control plane. Sorry, I forgot to tell that. So the Kubernetes administrator now has created the custom Ingress configuration and he has applied it at the cluster level. So for a particular host name, so you want to expose your mule APIs under a particular host, you have created the custom Ingress configuration for that host that we just saw, and you have applied it at the cluster level. Now, because you're applying it at the RTF namespace, and the RTF agent will automatically communicate that to the runtime manager. So when you come, once your Kubernetes administrator does this, if you come to a runtime manager and look at your runtime fabric cluster, you will see that endpoint listed, that domain listed, for which you had applied the custom Ingress configuration. So it automatically communicates to runtime manager and makes it available. So now that you have it available, you can, when you go and deploy a mule application into in runtime manager, you will have that listed in your dropdown. So now you can have multiple domains listed. All you need to do is in your Kubernetes administrator needs to create Ingress configurations and apply them in the RTF namespace, and the RTF agent will automatically communicate it to the runtime manager. And you can then choose which domain you want to associate with your mule application when you deploy it. And when you deploy it, again, the RTF agent will automatically create the Ingress resource for the mule application. You don't have to manually create it. It will automatically create it. And now the Ingress controller will know how to route the traffic. So from a customer perspective, all you need to do, install the Ingress controller as the first step. Second step, create the Ingress resource template that we just saw. So in that, you will specify the Ingress class name, referring to which Ingress controller you want to use, and all the routing rules and all that. Make sure it is applied at the RTF namespace. That's all you need to do. Now, the RTF agent will take care of communicating the domain information to runtime manager, And when you deploy a mule application, the RTF agent will again take care of creating the Ingress resource for that mule application so that the Ingress controller knows how to route the traffic. So all you do is, from your end, your task is much easier, because if this, before this came, you had to, there was a lot of dependencies. You had to, manage multiple Ingress resources. You had to use RTFCTL, command line utility, and all that. In this case, it's very similar to how an existing Kubernetes cluster would work. You can use your kubectl commands to apply that Ingress resource template, and that's all. That's all you need to do. Install the Ingress controller, Ingress resource, install an Ingress controller of your choice, create the Ingress resource configuration, and apply it to the RTF namespace. That's it. The RTF agent will take care of communicating and creating the Ingress resources. And all you need to do, your Mule developer, if you're a Mule developer, you just need to deploy a Mule application, select the domain under which you want to deploy it, and the RTF agent will take care of the domain. So we'll see all of this in the demo, but this is how it has been made easier. The RTF agent now takes care of a lot of things, and hides a bit the complexity from the customer end. So that is how the so I would highly recommend, if you're on self-managed Kubernetes, please, if you're on a version older than 1.11, please upgrade to 1.11, so, because these functionalities are available with 1.11 and above. So please upgrade your RTF agent version to 1.11 or above. And yes, after that it becomes much more easier to manage. So all you need to do is, your Kubernetes administrator just needs to come up with that Ingress resource definition that we just saw. So depending on the routing rules and what, that is your responsibility, because every organization might have different needs. But you install your Ingress and you apply the configuration. The rest is taken care of by the RTF agent. And again, I reiterate two things. It should be applied to the RTF namespace, and the Ingress class name should have the RTF hyphen prefix to it. Okay, next slide, please. So just some examples of Ingress resource templates, for your reference. And next slide, please. And if you see in the templates, there were some placeholders, like I told you, business group ID, environment ID, app name. So the RTF agent will automatically replace your application name with the actual application name. When it creates the Ingress resource for the Mule application, it will automatically replace these placeholders with the actual value. So you don't have to worry about that as well. Okay, so that brings an end to my presentation. There's a trivia question, and then we move over to the demo. So I think we can take over the trivia question. Which of the following is true when specifying custom Ingress resource configurations using the Ingress resource template that we just saw? We already have the right answer. Andy got the right answer. It's A, RTF namespace. The Ingress class name should be prefixed only with RTF hyphen, not BYOK hyphen RTF. So the answer is A. So Ishupal, I think we can now transfer the control to Mani.
Yes, thanks, Lakshmi. That was great. And Mani, if you can share your screen and then work towards that. Thank you.
Hello, everyone. This is Mani here from dialing in from Atlanta. And so just a quick background on me. So I am a MuleSoft certified integration architect, kind of doing integration for almost the last 20 years. I'm a senior technical architect at Extivia, and we are a premier MuleSoft partner for the last 8 years. So in our demo today, so let me show you the agenda here. So here is what we are going to cover. So all the things what Lakshmi mentioned, we are going to start creating an AKS cluster, which for the saving time, and I've already done that. And we will install a runtime fabric on that AKS cluster. And as Lakshmi mentioned before, this is pretty simple and easy. And then we'll move on to configuring Ingress controller. That's the key part. And we will enhance this Ingress controller to add more security to it. And we'll deploy a Mule applications, basic Hello World applications, and then we will kind of secure the traffic from the client to the Ingress, and we'll also secure the traffic from the Ingress to the backend API. And at the end, it will just uninstall and clean up. So before we get started, right? So we have some prerequisites. We need standard anypoint platform. You can always sign up for a free trial account, and because we are working on Azure, so we need a Azure CLI AZ, and you can just Google this, and there's a link here. And the next thing is Kubernetes. We need kubectl. That's a command line tool for working with Kubernetes clusters. You can get that also, download the zip file and then install it. We also need the RTF CTL, a command line tool to locally manage the runtime fabric. And here we are managing over AKS, and basic curl command just to ping the traffic. Okay, so let me show what we're trying to do here. So if you look at this, this is what we're trying to do. Now on the right-hand side, we have the AKS, the Azure Kubernetes Service, and so from the client standpoint, we are hitting this Kubernetes cluster, and there is a Ingress controller, the N, which stands for Nginx, and then you have all the mule parts, the RTF parts, basically all the services, resources, which belongs to the RTF namespace. That's all the parts we have here. And so this is all, and if you see all the logs here, so we are securing the traffic from the client apps to the Ingress control. That's part one of the demo. And then again, we are securing the traffic from the Nginx controller to the Mule application. So this is second part of the demo. Okay, so let's get started. Okay, let me go back. So our starting point is, because this is an AKS, right? So I will just show you the Azure, which I have already created, the AKS cluster. So first you need to create a resource group. I have created here and named it rg-mulesoft RTF demo. And in that, I have also created a AKS cluster. So now what we have seen before, the separation of the responsibility, right? So this belongs to the, this is not MuleSoft responsibility, and this is to be done by the customer. So because they, US manage this cluster, right? If you look at here, let me zoom in. So we're looking at a Kubernetes version for 121.7. Now the RTF version we are leveraging here is 1.12. That's the latest, and the Kubernetes version is 121.7. So I would like to emphasize one thing, that we go by the MuleSoft recommended version, which is, there are many new versions of Kubernetes like 1.22, 1.23, but the recommended version, which is compatible with 1.12 version of RTF, is anything which is 1.21.x. And then the X is version 3 or higher. So that's why I've selected 21.7 here. And if you see that I'm creating on East US, and I have one node pool, which has basically two systems here, two nodes here. This is what my cluster looks like. You got two VMs here, right? And the command to create that is, you can just simply create a so the first command is creating this is the Azure command line AZ, which we're creating a resource group, which is rg-mulesoft RTF demo. We're creating on the East US location, and the second one is creating an AKS cluster, right? And we're creating on the same resource group we just created in the previous step. We're calling that cluster as AKS MuleSoft RTF, and here you see we have two nodes, as you see the node count 2, and we're leveraging Kubernetes version 121.7, and we are going ahead with a standard DS2 v2. That's a VM size. So the DS2 V2 is the D series basically from Azure, and which gives you like 4 vCPUs and 7 gig memory and the 8 hard disk. Pretty, it's a good starting point. Okay, so let's head to, and then the second thing, like because you have already downloaded your AZ CLI and then you have logged in, so and then when you log in, it will pull up all your configurations. And we'll just do here is get the credentials for our resource group. So I'll head to just pasting it here to save time. So I've already done that, so it's merging, or also just get a new .cube. So it's in your profile, .cube/config is where it stores. So we're done with that, and so let's get to, so our cluster is ready, but we haven't done any, before we get started, I'll just show you what we have, the cluster details, right? So I'll just show you the namespaces we have and before and after. So if you see here, we got pretty much both 2 node pools here. We've got 2 nodes I was mentioning before in all the namespaces. So and let's head back to creating the RTF. So we head to Anypoint MuleSoft, we'll log in with our credentials and then head to Runtime Manager. So Runtime Manager is where we create our runtime fabric. So right now I'm doing this in my development environment. So you can, let me zoom in. So you see on this left-hand side, runtime fabric, and these are what I've played with before. So creating a runtime fabric, and you see here, these are the options. So you have seen this is your the last one is your runtime RTF appliance we talked about, and then you have 3 more flavors of Kubernetes here: AKS, EKS, and GKE. We're going to select AKS. I'm just naming that RTF AKS Atlanta demo basically. So that's the name. And read this carefully, because with flexibility comes responsibility, right? So this is something you need to understand and be prepared for it. And if you're not capable of managing Kubernetes and is required infrastructure, please get in touch with IT department. So right now I'm doing all the things, but there's a division of labor here. Your kubectl stuff will be done by your your IT department, the cloud folks, and then maybe the Mule. Anything RTF CTL will be done by the Mule admins. But again, this is overall support responsibility between divided along the line of MuleSoft versus the customers. So I click accept, and what you see here is a activation code here. So this is critical. So let me copy that. Let me just copy that here, and it's ready to be activated, right? And it's ready for activation. So the next thing I do is go back to my node, and I'm using a PowerShell, by the way. It's a command Windows terminal. So I'm doing RTF CTL. I'm doing a validate. So what this validate does is basically ensures that Kubernetes environment is running and it has all the required components are already existing, and the Kubernetes services, all the other services available. So it's just a validation step. If you look at let me zoom in. Ishbal, I'm audible, right? Or do I need to speak a bit louder?
You are audible.
Okay, perfect. And just pause a while and look at all this, what Lakshmi was mentioning before. So this endpoints, what you see is your runtime plane, right? So you have all, because it sees AWS, right? That's where the cloud, all the runtime plane is hosted. See, so this is ready, and you see this registry here at this endpoint, and so all the outbound network checks is successful. You see all the ticks, so it's all good. And now the next step is to do the install, and you'll really appreciate the ease of installation here. Just one command and you're done. RTF install. I just pasted the activation code of my runtime fabric. And you see what it's doing here. And this is critical. It's creating a namespace. That's the first point what Lakshmi was highlighting before. This is the key important stuff here. If that is wrong, everything will be messed up. So, and all the communication of the agent happens through this RTF namespace. Okay, it's creating a service account, cluster roles, all that. Oops, it is done. Okay. Okay, and if you see here, the namespace is RTF, status is deployed. Yep, and it's ready. So let's take a look. How does it look? We'll give it some time. It will be ready. Okay, I think while it's being ready, so the next stuff is to we can just see RTF throttle. I just want to do a status. If you see here, the connectivity, and this is the node, right? You have the AKS node pool, which I was showing, which has 2 nodes, and this is the agent. And oops, okay, I think this is nothing. Okay, I'm in. So this is the component, right? Agent, healthy, true, and then these additional cluster IP services, resource cache. So we're all good. So I think and these are the connectivity which I was talking about, the outbound connectivity here. Okay, let's head back and let's do a refresh, and yep, it's active. And this is the version 1.12. Okay, and pay attention here that your Kubernetes is 121.7, RTF is 1.12, and so the next thing we need to do is apply your license, right? So and for that, what you have to do is RTF-CTL and apply mule license. Oops, sorry, what am I typing? Okay. Apply mule license. And here, I would like to mention that you just don't put your license.lic. What you do is like Base64 encoding, right? To do that, you can just simply do this is my Ubuntu WSL. So all you do is Base64. So let's say you have the license.lic file. So all you do is W0 and your name of the license, license.lic file. Like I have already done that. And allow me to stop sharing because I'll be applying the license, and then I'll come back. Okay, I'm applying the license. Okay. Okay, the license is applied. Let me go back and share. And anyway, if you want license is the status of your license, you can always go to the license verified tool in MuleSoft. I kind of uploaded a invalid license, and it showed me that invalid or expired license. This license was expired like 2 years back. I just want to test it out. But again, we can always verify using this link here. But the one I'm applying is our partner license, which is valid till next year. Good. Okay, so the license, and the next thing is we need to attach this runtime fabric to one of the environments. So if you see here an associated environment, So I got all the environment listed out here because because this is shared. I mean, so sorry. What you can do here is like pick and choose which environment you want to associate this runtime fabric you just created. So I would like to do that with the dev. So you can also put a attached to one of the business group. I'm leaving it as default, and here I'm saying apply allocations. So this is attached to my dev environment. And next thing is so we're done with the installation, by the way, right? So now we're moving ahead with configuring our. So this is what we're right now. We're done with installing Runtime Fabric on AKS cluster number 2. We're going to focus on configuring Ingress controller, right? And for that, see, if you see here, there's a message out here, like you cannot manage endpoints for apps deployed to this Runtime Fabric because Ingress has not been configured, right? So work with your central IT team to resolve this issue. Basically, this is the responsibility of the customer to kind of commission an Ingress controller here. So that's what we'll be doing now. Okay, so to get an Ingress controller, you can simply get a, in this scenario, right, you have many options when it comes to an Ingress controller, right? You can go the Nginx Ingress controller, or you can get an HA proxy. There are many ways, right? But what I'm using here is a Kubernetes community supported Ingress controller, I mean Nginx Ingress controller. And for that, all you need to do is, let me bring it to my cheat sheet here. So this is the so this is the command to apply that. And if you're curious, you want to see, this is the deploy YAML. So basically, this is the deployment YAML, and all you have to do is apply this. It's a long one. You see all the roles, cluster roles. It's a lot of things. So I'll just apply this deployment, and so this is creating your Ingress controller. Okay, and the next step is configuring that Ingress controller. So you have seen the Ingress template YAML file. I'll bring it up again, and we'll see a few things here. So if you see here, the kind is Ingress. So this is we're going to apply. So we have done the installation of the Ingress controller. Now the second step is we are configuring the Ingress controller, right, for the Runtime Fabric. In that configuration, you see here, like remember what Lakshmi was mentioning before, that the beauty of doing a custom Ingress controller here is like you have more choices here. So the choices are, you can pretty much do a URL path renaming, right? And then if you go back, I'd like to take you back to the 4 points, which here, these 4 points, right? So you can get URL parameters placeholders, and you can do a TLS and HTTPS configurations, and you can also do multiple Ingress controllers within the same Runtime Fabric instance, and also multiple Ingress configurations to choose for applications. So we'll just use one each for these two, and then I'll show you in the demo the TLS and HTTPS configurations, and also the URL parameters placeholder. So let's go back, and this is where we are doing a URL rewrite here. So we are rewriting. So basically, what you're doing here, we are leveraging this Ingress template for a path-based routing, right? So, and in where your application name is part of the path. So this app name, you have seen all the placeholders, which is your application name or the path, and it is inside of this RTF namespace, and your Ingress class name starts with RTF namespace. I mean RTF hyphen, and Nginx is the controller we are leveraging here, right? And the host is I have just selected the diff. I have selected rtf.example.com, and you may choose whatever applies to your domain name. See the path here is the app name, and these are just for illustration purpose and not having any significant meaning here. But the key part to key takeaways are you can rewrite, and you can do the path placeholder, these two things, and all inside of this RTF namespace. But that is the key thing to communicate between the agents, and a lot of features surrounded within the RTF namespace, as we discussed before. Okay, so let's head back and apply this template, right? So kubectl apply -f, not bad, ingress template.yaml. Well, it's created, and I'd like to take you and then just show what has changed so far. Let me do a kubectl get parts and all namespaces. Just want to see a complete picture of what has happened so far. Oops, what did I do wrong? One more hyphen, okay. Okay, so if you see here, just take a look. So we got namespace, right? This is the Ingress Nginx. This is the for Ingress controller, and these namespaces are kube system. This is the cluster we created from Azure, and I think we were talking about CSI and all that stuff, right? So this is all here, and the metrics is all part of the AKS cluster. And then the bottom here are your RTF namespaces, right? You have an agent, you have the cluster IP service, and resource cache. So these three are the main things. And yeah, so it's all ready. And if you look at here, and now it's the clean slate, right? Now we're going to deploy the application. So I'll take you back to, we did Ingress controller configuration, right? And then see what changed here. Earlier, we saw the inbound traffic was giving us an error saying that go do the configuration of the Ingress first. And now this is what we have already applied, RTF, for example. As I mentioned, you can change these endpoints. It's up to you. And one more thing I would like to digress here and mention about the log forwarding, right? And we're emphasizing a lot on whose responsibility is what. So I think a key component of that is the log forwarding, right? If some issue happens tomorrow, right, in your an RTF cluster or anywhere or app, who knows where it is, right? So you always want to do your troubleshooting, and for that you need to do log forwarding. So you can forward your logs to any point monitoring. For that you need a Titanium subscription. I don't have a Titanium subscription, that's why it's grayed out. But if you have Titanium, you can just select this and then go to your endpoint monitoring, pull up that, and see all the logs. Other options are you can just do, because you are this RTF is running on a Kubernetes cluster, right, in AKS. So you can leverage all the AKS monitoring tools you have, or you can even do Splunk for Kubernetes. There are many tools to see your logs, you know. And just to let you know, all the pods this into standard out, and then your console basically, right? You can always go there and do a kubectl, you know, logs, and then go into that container and go to the app. You can always see the logs, what is being printed. But better way is to forward to an external tool so that you can quickly figure out where the issue is and quickly do the troubleshooting. So that's the best practice. Okay, so let's get back. So we did, just to revise where we are, we installed the Runtime Fabric cluster, we created the Ingress control, we configured it, and next thing is we will deploy a Mule application, right? So for that, let's go to application and deploy an application. So we'll just name it a hello world. I'm just naming something 222. So one thing you'll notice, and you'll really appreciate that. See, if I'm changing to Cloud Hub, right, and if I'm changing to RTF, it's pretty much the same. Right? I mean, except the a few minor differences. But again, it's the same thing almost. So I'm selecting a runtime fabric on my deployment target is the runtime fabric, and the version is 4.4.0. I'm selecting 2 replicas, and I'm just leaving it as it is. And the beauty of it is this, like you can, just like Cloud Hub, you can do a rolling update or a recreate. So I'm going to select a rolling update, which is having less downtime. I'm keeping it, this is a hello world application. I'm not bothering too much on my resource usage. I'm just keeping it at the minimum, 0.02. Memory is at the least 0.7, CPU 1.9. It doesn't really take in much here. And the next thing is Ingress, right? And I'm just keeping it as the default. This is what we have configured in our Ingress template here, right? rtfexample.com, and this is the app name as a placeholder, which is hello world is my application name, right? 0407-2022. You can also add additional endpoints, and that's the beauty of having a custom Ingress resource. Okay, let's get a quick, easy, hello world from the Exchange. I'm getting it from Exchange. Just get an example from Exchange. Okay, here is the MuleSoft one. Selecting this. Okay, deploy the application. And remember, I selected 2 replicas. And if you see the status, undeployed, and let's head back to our command line and see what changed. You see this hello world. So we got a new namespace for our app. This is the hello world. It's running. Okay, it's ready, which is good. So we got 2 replicas. So see how it was 1 of 2, 1 of 2, and then it turned to 2 of 2. And now both of them are 2 of 2. Right, so we are running 2 replicas here, and status is running. So let's go back and see these 2 are started, right? So all good. Our application is running. Going back, and this is running. Okay, and let's just do a quick test. So just head back to my. We'll just do a curl on that. I think I have that copied somewhere. Oh, well, one more thing before we go and jump into running this. So we need to, we cannot look at this URL what we have here. So we have an rtfexample.com, which is and hello world, right? We cannot ping this from outside, right? Because this is just a private name, right? It's not a public. It won't resolve into a public IP address or something, right? So we cannot ping this. So all you need to do, and that's where your Ingress helps. Because you applied an Ingress, and we can configure that to get an external IP address from. We can get an external IP address of that Nginx server we just configured, right? So the command for that is to go back there and do a kubectl and get services and services for that Ingress Nginx, right? So what this does is it will give you a public IP address. Oh, sorry, it's the wrong window. Okay, and take a close look at. So we have for our Ingress controller, the first line, right? That is the controller, right, which routes your traffic. It's a type load balancer, and look, this is your internal IP address 10.0, which is a private, and then you have this external IP, which is 20.121.253.174. Let me copy that. Okay, so you may have. It just gave me in one try. You may have to try a few times for that that external IP address to be supplied to you. The same command multiple times. So let me go back to my cheat sheet and So now we'll do a curl. And well, it didn't change from the last time I ran this. Looks like 21, 20. Okay, I tried this many times today just to make sure things works. Looks like it hasn't changed the IP address. Okay, so let's do this. So what we're doing here, what I'm highlighting here is we are resolving through curl, right? I mean, this is just for testing purpose, but yeah, I mean, in real world, you'll just sort of put do DNS configurations to resolve this RTF example, your domain name into an IP address. That's something to be done by your, cloud team. But I'm just for testing, but I'm just doing a basic curl command to show you this works. So just doing a curl on this, and oops, and there you go. You have a hello world replied. This is working. And just to know a few things, we are not securing the traffic, right? Which I was telling you before. Just doing a basic deployed an application and configured the endpoint with Ingress, and we're just testing. Nothing secure here. The traffic is not secure, and you see the HTTP here. Okay, so that's done, deploying the application. So I'll just take you further and do this, right? So this is just revisiting where we are, right? So we created an Ingress controller. I mean, we created a cluster. We deployed RTF on that AKS cluster. We created a Nginx Ingress controller. We configured the endpoints with that Ingress template. And then we are going to do the first part, securing. We're going to put a lock on our traffic, and the traffic we're locking here is between the client, which is my terminal, and the Ingress controller. We're going to secure this here. So for that, I'm just going to use a basic security mechanism. In real world, you may not do that in production. You may want to go with a more sophisticated security mechanism. But for demo's sake, I'm just doing a basic TLS. So for that, let's head back. Okay. Okay, so we need to create a bunch of certificates and some private keys, because we are going to leverage okay, so we are going to generate a bunch of certificates, which I've already done, like generate certificates and some private keys, right? I'll just quickly show you what those commands look like. And look at this. So I'm going to do an OpenSSL. You can simply, I'll just show you. I already have those listed out here, but I'll just show you in a different folder so that just to. So what I'm doing here is creating a certificate for with the common name of rtf.example.com, and I'm creating a private key out, key PEM, and certificate is cert PEM. So these are my private key and certificate, and I'll just give you that. Oops, I have to get a write permission here. Yeah, that's fine. I mean, I've already. Anyway, I've already created I need some permissions here. I've already created that. I mean, this is not a key part. Okay, so we have the certificate. Now, the next thing is we need to apply this certificate, right? So let's use that certificate and private key and apply to our Kubernetes cluster. And we are going to create a Kubernetes secret. And the command, it's a kubectl create secret TLS example. I'm just checking if I have that out here. Looks like I don't. Just type it then. Kubectl create secret. We're creating a secret, and what kind of secret? We're creating a TLS And the TLS name is example-TLS. And which namespace I'm going to create? I'm going to create inside, you know what I'm talking, so RTF, right? That's the key. And I'm going to, the key which I have already created is the key.pem, I think, right? Yep, key.pem, and I have certificate like cert.pem, right? Cert is cert.pem. So this will create a Kubernetes secret, right? It's created a secret example TLS created. So we're good. And next thing is we're going to create, remember, you know, when the advantage of creating a custom Ingress template or resource is like you have the flexibility to do the security to that, right? And which again, I'm taking it back of this, right? TLS and HTTP configuration you can do. Okay, so let's apply that. So in Ingress template, I'll just show you. It's already out there. I'll just so this is what we had initially, right? An Ingress template, just a basic non-secure, and all we are changing here is adding a TLS, and that TLS is you add a spec TLS here, and so this is all it's changing here. This highlighted section here. So we're adding a TLS to the host rtf.example.com, and we already have created this secret, right? Example TLS. We just created in Kubernetes, right? So that's all pretty much, and nothing else changed here. Only these this block of configurations for TLS. And let's apply this. So let's do the kubectl apply -f and Ingress TLS. Okay, so it's applied, and then we need to do a quick test using curl. Okay, it's a long one, so I already pasted it out here. So take a moment to see what changed here. So the thing changed is HTTPS, right? We are making it secure, and we are also look at the port. It's changed to 443 here, because so 443 is where the Ingress controller listen on for secure traffic. And I put a V there just to make it verbose so that you know what has been applied. The V stands for verbose. And if you see all this TLS, it's a lot of messages here. This is just a demo certificate. You can see here it's saying fake certificate. That's interesting. And we're applying to this host rtf.example.com and all blah 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 stuff here. And at the end we see that nice hello world again, right? So we're making this the first part of the traffic secure. Okay, good so far. Okay, so now what we need to do is, so we have done the security between these two, right? And the second step is now we need to secure the traffic. Keep on. Okay, now we need to secure the traffic between these two, right? So our Ingress controller and the Mule applications. And I mean, you guys have done securing Mule applications many times before, right? All you have is a all you do is get a key store. You already have a certificate. Get a key store. Store that certificate in that key store, and that's in your Mule application. So we'll just quickly show you. So there are two things here. One, what you secure your applications, right? You open that Hello World application in Anypoint Studio. You secure that with a TLS. And the second thing is you secure that you tell Nginx resource, and basically you configure in Nginx to secure the traffic between Nginx and the backend. In this case, is our application, real application, hello world application, right? So let's do the first part, the easy part, right? And that's, I mean, both are easy, but I'm just bringing up this hello world example here. And all I'm doing here is creating a TLS context. And as I mentioned, you guys have done this many times before, nothing special about this. So the TLS context I'm creating, and I'm putting a key store, which I have, generated using this command out here. And by the way, this is called last mile security. It's last mile, which is to the application, right? So we have the edge secured with TLS. And now we are edges between the client and the Nginx controller. And now the second phase of that is between Nginx and the hello world application, the backend, quote unquote. So if you see, this is the command for generating again a private key, key.pem and cert.pem. And if you see here, this time I'm changing my common name to hello world, right? Because if you see this common name, in the previous step where we are securing our Nginx from the front-end traffic, we created two keys, key.pem, cert.pem, and then common name was RTF example. For securing the backend, I'm creating another set of key, and again same name, which is going to overwrite, and again with a different common name, which is hello world. That's my application name. So I have my certificate ready, I have my key ready. I'm going to put all those out in a package them into a key store. So that's the command OpenSSL pks export out. Use the certificate and the key. So you get your key store, and that's what we have seen it here. So keystore.p12, so passwords, whatever you have given, and then one more thing here is the HTTPS port. It's 8081. Okay. So this application is ready, and I have already, and then once your same application, you just export that into a jar file, which I've already done. So our application is now changed into TLS, right? And now let's go do the front end. Now let's configure that ingress, right? In this case, we're going to secure the backend traffic. And let's open up the same template and make some few changes. And I've already done that. And if I'll do a side-by-side comparison between Ingress TLS. Move to the other view and take a notice what changed. So all it changed here is this annotation. So everything else remains the same. And we are adding only one annotation here, which is Nginx Ingress Kubernetes IO/backend protocol changed to HTTPS. So this is the only line change, which is securing the backend traffic with HTTPS. It's as simple as that. Nothing else changed here. So let's apply this template. Okay, so this has been applied, and now, because see, we are testing from the client perspective, right? We're testing from here, we are here, right? This is the terminal, right? So it really nothing changes for the client, how the traffic is secured, how the traffic is behaving from the Nginx to the pod. So, I'll just use the same curl command I had used before. Okay, so this is the same curl command from a client standpoint, nothing changed. And again, I'm getting a response back. So this kind of completes our securing the traffic for both the front end and the back end with TLS, basically. So I think that's all pretty much. So just to revise what we have done, taking you back to our demo outline, you need to create a cluster. And I already created, I have shown you that. And installing a runtime fabric on AKS cluster, we did that. We configured the Ingress controller just the basic configurations. We deployed a Mule application with a new endpoint, and we secured the traffic from the client to the Ingress. We secured the traffic, the last mile security. We secured the traffic from the Ingress to the backend, and that's all pretty much, right? And these are the key things. And if you want to do the monitoring stuff and all, and you can always, as I mentioned, you can leverage Azure if you want to, because you are inside of this whole thing is inside of AKS cluster, right? So all the monitoring features of AKS applies here, right? So I will just show you quickly how our cluster looks like now. Oops, what am I typing? Cluster info. And look at what's happening. So your Kubernetes control plane is running at AKS Mule RG. There's a link for it. EastUS Azure 443. That's your control plane for Kubernetes. Your core DNS, which is from that Ingress, and a metric service running. So 3 are running. This is all the cluster we created in Azure, right? And I just want to show you. Get the deployments. We did a bunch of deployments, right? We did apply a bunch of deployments for Ingress. So I will show you all the namespaces. Oops. This is equals to true. Okay, again, I missed one hyphen here. So if you just to summarize what we have, all the deployments we have in Ingress Nginx. We have the Kubernetes namespace, we have the RTF namespace. Within that, we have an agent, we have a deployer, we have a Mule cluster IP, and a resource cache. That's all pretty much it. And this Hello World application is on its own namespace here, 2x2 ready. Okay, so I think the next step before I get into, let's do a trivia question. So here is your question. So which port or ports a Runtime Fabric application has to listen for HTTP and HTTPS? Select the correct one. There is no all of the above because that's not true. So
yeah, we already got before you even completed the question, we had the answers.
Oh, great. Yeah, many times skip through this page. Good. Okay. So that brings to an end of things. And before we go, as a leave no trace, right? So I'm going to clean up everything because I don't want to pay my my licensing fees here for Azure. So I'm going to do a cleanup, and the command for cleanup is rtfctl uninstall. And before let's do that. And it says okay, confirm, which I will do. Confirm. It wipes out everything. Well, it wipes out your RTF stuff only. Then I have to go and then clean up from my Azure. That I'll do later. I just want to show you the cleanup stuff here. And it's going to wipe out the application also. Okay, I think, yeah, this will take maybe like 30 seconds or max a minute. Do we have any questions? I haven't checked the chat window.
There were a couple in the Lakshmi was answering those. But there was one, what other kind of security other than TLS can be applied between Ingress and pods?
Yeah, I mean, you can go, pretty sophisticated in terms of security, all the way between, your tokens or OAuths. You can, what I have shown is just a very basic. Typically, you don't do that in production. Security in Kubernetes is a completely different topic, and it's very advanced. I mean, you can as I mentioned, do many advanced security mechanisms, SAML, SSO tokens, or OAuth, OpenID, all of that. You can do that. It just depends how much you want to, what kind of security you need. And then again, your Ingress controller offers you all those configurations. And you just like I was showing you, like we were enhancing that Ingress template, right? So you will go back and modify that Ingress template to add more security. Okay, well, done. So Runtime Fabric is uninstalled. So we go back and see how it looks. Well, it's gone. Runtime Fabric is gone. It says disconnected. So I'm just going to go delete. I'm going to delete and do a force deletions in my dev environment. You don't do that. First you undeploy the applications, then you do this. Yep, it's wiped out everything. Okay, so that brings to the end of my presentation here. Over to you.
Thank you so much, Mani and Lakshmi. This is very informative. And if there are any questions, we are happy to take them now, or you can reach us through the forums as well. The recording would be made available tomorrow in the Meetup page.